In this presentation, I'm going to give you a high-level overview of C# and the .NET framework, give you a sense of what the feature set that's built into C#. And then at the end, we'll wrap up and move on to an activity where you set up Visual Studio and follow along and make a little project yourself, which is kind of a fun little project. So in this activity, just sit back, relax, watch the show, and hopefully you'll learn to appreciate C# as much as I do. C# is a high-level programming language developed by Microsoft. It is Microsoft's clone of Java. It's actually their second attempt at a Java clone. They had a language called J++ way back 20 years ago, and it kind of went nowhere. So the joke is they took the J, bent it into a C, took the plus and squished it together into one thing, and now that's where C# came from. That they like just squished the J++ logo to make a new logo. It has a great set of tools for building interfaces. It supports Windows Forms and WPF, so there's actually two interface builders built in. There are templates for building all sorts of projects, so no matter what you need a language to do, C# can probably do it. And it has a feature set called LINQ, which stands for Language Integrated Query, and it is a set of features that makes data access very, very easy. So instead of having to learn multiple technologies depending on what your data source is, now you just learn one framework or one set of syntax, and you can use that for all sorts of collections and databases. And it's really, it is a very, very powerful feature, and I now that I kind of have it under my belt, I really appreciate it, and I really like it. C# has garbage collection, just like Java, so you don't have to worry about destructors. You don't have to worry about memory allocation. If you're coming from the C++ world and every time you malloc something, you have to free it, or every time you new something, you have to delete it, you don't have to worry about that at all. But that doesn't mean that you can be lazy in C# if you have an external resource open, you need like a file or a database connection. You have to make sure that you close it. So, and C# provides mechanisms for doing that. But generally, you don't have to worry about memory management. That is all handled for you by a garbage collector. So another great feature of C#. You never have to worry about managing your own memory again. So C# versus .NET. This comes up because you see a lot of ads, or job postings that are, we're looking for a .NET developer or something. And it's like, okay, well, what do you mean by a .NET developer? What is .NET? Well, .NET is a framework. It is a set of languages and associated tools. C# is one language within that framework. So it's like, okay, well, a C# programmer is part of uses the .NET framework, but maybe they're looking for a VB programmer or something. So when you see we're looking for a .NET programmer, that kind of means like they don't know what they're looking for. It's like, okay, can you be more specific, please? So .NET supports several languages: C#, VB, F#. So all of those languages are part of the .NET framework, and they're all compiled down and can be run by the same virtual machine. So they're all part of a framework. Just keep that in mind. And what does that framework look like? Well, here's a nice pretty picture of it from the Microsoft documentation. Notice that we have several languages up at the top: C#, VB, F#, JScript. And these can all be compiled down into a common intermediate format, which the name for this has changed over the years. Sometimes in this slide, it's the CIL. I've also heard, IL, intermediate language, MSIL, Microsoft intermediate language, and that is sometimes pronounced as missile. So when you hear the term missile language, that's what they're referring to. So when you write your code and you build your project, it is kind of half compiled down into this common intermediate language. It's kind of like an object-oriented assembly language. And then when you double-click on your program to run it, that intermediate language is fed into the JIT, the just-in-time compiler, which compiles that MSIL into code that can be run by the common language runtime. So the common language runtime, or the CLR, which is installed on your machine, is kind of the virtual machine. It's the compiler and virtual machine that actually executes the code. So when you build your project, it's kind of half compiled down to an intermediate language. When you double click on it to run, the JIT actually turns it into something executable, and that executable code is then run by a virtual machine. So it's similar to Java, but a little bit more complicated because of we've got this JIT. Although I think Java has the JIT too. So that's how it works. So that's our tool set. And you can see that there's a lot of stuff here. So this is the framework. The .NET framework is all of these languages and all of these associated tools. And we'll talk about the pros and cons of this system in a couple of slides. Like what do we get out of having a complicated framework like this that has multiple steps? And the answer is actually we get a lot. One of the features of the framework is that we get something called interoperability. So if we back up a slide, you can see that once something has been turned into Common Intermediate Language, IL, MISL, whatever you want to call it, we don't really care whether it was originally C#, VB, F#, JScript, whatever. So if we write a library in VB, we could consume that from a C# program. So that programs written in different languages can all kind of consume each other's binaries, right? So that's interoperability. That is one of the features of this framework. Now, with respect to the C# language itself, it is a strictly object-oriented language, which means that everything has to be inside of a class. You can't just have a function dangling out in the middle of nowhere. And that's very similar to Java, or it's exactly like Java. In Java, you just can't write a function. The function has to go inside of an object. C++ is not like that. You can just have a function. You can basically write C code in a C++ compiler. Python does not require you to put functions inside of objects. So it's possible to write really, really sloppy code. C# enforces strict object-oriented behavior. So any functions you write, any variables have to go inside of an object, right? So an object is going to consist of functions and the data that those functions need, or you can think of it as an object's state and the functions that manipulate that state. So a class is just a wrapper around some variables and some functions that models some sort of object that makes sense within the context of your program. And everything in C# has got to go inside of an object. There's no global variables. There's no kind of dangling functions outside of libraries. Everything has got to go inside of an object. And I already said that. So here's a picture of it. So imagine we're writing a game called Space Invaders, right? Well, a Space Invader is a kind of conceptual object in our game. It is going to need variables that store its state, and it's going to need functions that change that state. So a class is just a wrapper around some data and the functions that use that data. So everything in C# is going to go inside of a class. Now, if you have lots and lots of classes, how do you keep all of that organized, right? And that's where we get a namespace. So a namespace is a wrapper around a class that bundles many classes together into kind of a common unit, a common library, a common entity, you can think. And the reason I'm mentioning this is because when we create our first application, you're going to see namespaces, you're going to see classes. So a lot of stuff will be pre-generated for you. And if you understand that everything that we make has to go inside of a class and that those classes have to go inside of namespaces, that code that you see will make a lot more sense. So this is just kind of an overview of how stuff is organized within one of your programs. So namespaces are the outermost wrapper for organizing things, and inside of that you'll have your classes. What other stuff is cool about C#? C# can do lots and lots of things. It turns out you can write iOS and Android apps using C#. If you use the Xamarin tool chain, Xamarin is a cross-compiler. I do not believe it is free. However, I see a lot of demand for Xamarin because from a corporate point of view, would you rather have two code bases, like an iOS code base and an Android code base? Would you rather have to pay Apple developers and Android developers? No. You'd like to have one development team that uses one set of tools that can produce an application that will run on multiple platforms. And Xamarin is a framework that can do that. So if you're wondering how does C# get used in the real world, well, on the front end, certainly Xamarin. You can also write the backend for web services using C#. If you have a AWS account, you can see that there's all sorts of, you can write C# programs and upload them to be the backend for your web services. So C# can do the front end, C# can do the middleware and the back end. It's kind of a language that you could use almost anywhere in the development stack. Like Java, C# espouses the write once, run anywhere credo or motto or ethos, whatever you want to call it. And that is possible by that system of the intermediate language and the JIT and the common language runtime. So you can compile your program into that intermediate format, and then you can run that intermediate format anywhere you have a common language runtime installed. So there's a project called Mono that is a open source .NET language, .NET framework runtime that you can install on your Raspberry Pi or on your Mac. And that allows you to run applications written on your PC on any of those other platforms, right? So because the program is executed by the virtual machine, the common language runtime, we get location independence. We can run that program anywhere the virtual machine, the common language runtime, is installed. So portability is a major feature of the .NET framework. So let's look at some alternatives to the .NET framework, and that'll really help us kind of see how this system of intermediate language that is just-in-time compiled to be run by a virtual machine really helps us out. We can see we'll look at some traditional compilation and traditional interpreting of code, and then we'll be able to see that the system that the .NET framework uses is a very, very good compromise between the two that gets us almost all of the benefits with none of the downsides. So traditionally, like if you're like me and you learned to write C or C++ back in the 90s, right? You have a compiler and you compile your code for a particular platform. You target a particular architecture, a particular processor. So there's a compiler that takes in your file and it spits out a binary, and that binary can only be run on that platform with that processor. So that code is tied to a particular processor. It's not portable. That's the downside of traditional compilation. Traditional compilation is very fast because the CPU is executing native code, but you can't take that PC program and then go run it on a Mac. It just doesn't work. So that's the pros and cons of the traditional compilation strategy. Like on Linux or Unix, whatever, you compile your C code, and now that code will run very quickly on the machine, but you can't take that code and run it somewhere else, right? So native code is fast, but not portable. And the other way of kind of writing a program and executing it is it's kind of like the way you'd run a scripting language. You write your script and then you run your script using an interpreter, and the interpreter actually turns your code into a model and executes that model. And these are the traditional scripting language, like Python, JavaScript, all the Unix shell scripts, Linux shell scripts, the ancient BASIC programming language that was interpreted as well. So interpreted programs are portable because you can take that Python file and run it anywhere there's a Python interpreter. But the problem is your program is being run by the interpreter, which is a program. You have a program running a program. That makes the execution slow, right? So when you run your Python program, the Python interpreter has got to read that file, build it into a big tree and have some memory, and then it's got to crawl through the tree anytime you do. Basically, it's got to execute that model and then write out the output to the console. So the fact that you have a program running a program makes this process slow. So if you line up, I've done this. You take the Knight's Tour problem. You write it in C, you write it in Python, and the C version completes quickly, and the Python thing takes 15 minutes. The interpreted code is very, very slow. But it's portable, right? So that's the other end of the spectrum. Interpreted code is slow but portable. And the idea is, well, couldn't we have some sort of compromise that gets us the best of both. And before I blast off here, let me do a demo. So here's what we're looking at, the trade-offs. Compiled languages are fast, interpreted languages are slow. So let me go do my little demo here, and I'm going to show you the speed difference between compiled code and interpreted code. And then we'll talk about how this relates to Visual Studio. So let me pop over to MAME, the Multiple Arcade Machine Emulator, which is a really great debugging tool. And you could think of this as a virtual machine, just like .NET has the Common Language Runtime. You can see here's this window is our code that's being executed, and PCS, CC, DP, AB, D, X, Y, U, those are the registers in the processor for the machine that is being emulated. A virtual machine is, you could think of it kind of as being very similar to an emulator. And let's take a look at a program here. So, and I love this, made by Microsoft in 1982. That's hilarious. You know, that was how Bill Gates got his start, was writing operating systems for these old machines. And, oh, IO error. Let me go load the disk image. All right, there we go. So I'm going to type in the dir command. And I don't know if you can hear that. It actually emulates the sound of the floppy disk running. So I have two programs that are essentially the same thing. Colors and test. And Colors is a basic program. Basic is an interpreted language, which means the code is run by the interpreter. And actually, let me load that program for you. Let me load Colors. And we hear the floppy disk running. And then I'll type list. There's the program, right? So it's just like a Python script, right? It's just a little script. And let me run it. And that's all it does, is it just fills up the screen with different colored squares. So basic, portable, but slow, right? I could take that basic program, type it in on another machine that supports basic, and it might work. So actually it wouldn't, because the memory addresses are different for the video RAM. But by and large, basic programs are portable from one machine to another, as long as they're just working with text or numbers. All right, so that was a basic program that was interpreted but slow. So let's look at our disk and see what we've got here. And I think let's look at test and see what that does for us. All right, I had to look up the commands. I forget the commands for run these ancient machines sometimes. So to load a binary program, right? This is our compiled program that's a native machine code. Let's load, it was load M. There we go, load machine language program. Let's try test2.bin. That will load. And now let's exec it, right? So let's compare the speed of this program to the speed of the last program, and boom, it's done. Okay, so that is the speed difference between interpreted code and compiled code. So on one of these old machines, the compiled code, the native code, the machine language code, the binary code, that is about 300 times faster than the interpreted code. So there, the speed trade-off is quite noticeable. Now let's go back to finding how do we make a compromise? How do we make a compromise? And that's what this .NET framework gives us, right? What we do is we compile our code down to an intermediate format, and then when we run it, we have a virtual machine that executes our portable binary code, right? So what this framework does for us is we target really a virtual machine, a kind of a theoretical machine. We compile down to this fake machine architecture, and then we make a program that pretends to be that fake machine, and it runs the binary code. And that way we have the benefits of compiled code. We get the speed of compiled code and the portability of interpreted code. And that's what this .NET framework gives us. It gives us all of the portability and almost all of the speed. There you go. So hopefully that gives you some idea of the pros and cons of this. Compiling, interpreting, isn't there some way to get the best of both worlds? Yes, you compile down to an intermediate format, and then you make virtual machines that run that intermediate format. right? And then here are some different, like CLR, Mono, .NET Core. These are .NET runtime environments that can execute that can compile and execute your intermediate code. So, so .NET code is actually portable. And that helps you, that can be useful, because imagine you're trying to write the back end for a web service, and you're going to deploy it somewhere, but maybe you don't know what kind of machines are being run, are on the back end, right? So the portability there is a major selling point. So in the next activity, what we'll do is we'll open up Visual Studio and install it, and or you can do this at home, and then we'll make the first project, which is the moving button of great annoyance, which will just get us used to like looking at namespaces and classes and building an interface and writing some simple code. So if you have not installed Visual Studio before, you do not have to create an account. Just when you launch it, it'll say create an account. There's a very small little bar that says maybe later, or a small little, like just click that, and then make sure you select C# as your default language. And that way, when you go to create a project, it will give you C# project templates as opposed to like C++ or VB project templates or something like that. So just when you're installing Visual Studio, those are things to keep in mind. So thank you for your patience. I hope you found this somewhat interesting. And then in the next video or the next activity, that'll be more hands-on. We'll get to writing some code.